Hello and welcome back for another VMK in the C++ series. In this VMK we're going to continue working with classes, and specifically I'm going to show you what the copy constructor is all about. This is a very important concept to use whenever you're creating classes that have dynamic memory within them. You don't want to be stepping on any memory as you're copying one class to another or constructing a class from another class. So what you have to use is a copy constructor. So that's what we're going to be going over in this video. Let's go right into Visual Studio and create a new project. It's going to be a Windows console project, and we'll call this copy construct. Under application settings we'll have console application selected, and here's our main entry point into our program. Now, because we want to be using some classes, I'm just going to create a very simple class up here. And this is the class that we're going to be using to demonstrate how the copy constructor works. So it's called user, and we have a constructor which initializes our two member variables. We have something called m_szName and m_IAge. Initially, this user will not have a name, so we set this parameter here to be null because it's a pointer to a character string. And the other member variable is an integer, so we're just going to set it to some value, let's say 20. Our Destructor is going to be responsible for cleaning up any memory that we allocate to this name member variable. So if there is something allocated in here, we're going to call delete on this member variable, not forgetting to put in the square brackets here to tell C++ that this variable is going to be an array. We then, after we delete it, we set the member variable equal to null. This is just to stay safe. Doesn't really serve a purpose now because after we go through this destructor, this variable is no longer going to exist. We also have two functions inside of this class. We have setName, which we'll use to set a name to this class. We'll pass in the parameter into here, and if the parameter that we pass in is null, we're not going to do anything, so we'll just return. Otherwise, we'll take this guy, which is our member variable, and check to see if something has already been named. If it already has a name, what we're going to do is delete whatever's in that name and then allocate new memory and copy whatever was passed into here into our member variable. If nothing was already in here, we don't delete anything. We'll just go in, allocate however much memory we need, and then we copy whatever gets passed into our member variable. The other function we have is showName, which all it's going to do is it's going to display to our screen what the name of this guy is, and that's it. If there is no name, we're just going to display no name. Then down below here, this is where we define our member variables. We have a pointer to a character, which is that szName, and we also have an integer. Alright, so to use this class, you would do something like this. You'd specify we want to create a member variable inside of the main, and it's going to be a class type of user, and we'll give it some name here. Let's say U1. So after we do that, we can go and, for instance, call showName to display to the screen what the current user's name is. Then what we're going to do is we're going to set the name. Let's say we're going to set it to Matic. And finally, we're going to show the name again. Oh. Alright, so let's run this program. Control F5. And what we see on the screen here is it displays no name because initially the class has no name, and then we initialize our name to be Matic, so we display that to the screen and then we return normally. Now, let's say for whatever reason we want to create another variable. Let's call it user U2. And somewhere in our code, we want to associate U2 and make it equal to U1, like so. If we were to do this and run our program, we would actually make our program crash. And let me demonstrate that. Control F5. You notice it runs, it displays no name, it displays Matic, but then it crashes. Now, the reason for this crash is not because of this assignment, but rather because of the destruction whenever the program finishes. Let me demonstrate this. If I put a breakpoint into here and I run my program, everything is fine, There is no crashing yet, and you can see here we display the no name, we display Matic. We're right here, right before we assign whatever is pointing inside of here into our user 2. So we're about to make the assignment from user 1 into user 2. Press F10 to make the assignment. The assignment passes. Everything is fine. However, when we go in and actually run through here to exit our program, that's when we get this bug showing up. Now, what is really going on here? Okay, let's rerun our program again, but this time let's take a look at what happens with the member variables inside of U1 and U2. So we're going to run it. We're stopping here right before we make the assignment, and under the watch window here, we'll just display U1 and U2. Notice that U1 has already been set to have a name of Matic, so here our member variable SZName is at memory address 323C20 and its value is Matic. The U2 variable doesn't have a name right now, so it has null for its member variable, and age is set to 20 because that's what the default constructor set it to. Now notice what happens when I execute this line of code. Oh, sorry, pressed the wrong button there. F10. As soon as I make this assignment, what C++ does is it takes the variable here, SZName, and assigns it to the same memory that this guy here was assigned. Well, what this really means is U2 and U1 are sharing the same memory space for their name, which means if I go in and change Matic in U1, the name in U2 will also change. And that's not what the behavior we want, because we actually want to have U1 have a single name and U2 to have a different name, and they shouldn't be linked together. Let me demonstrate that. If I take U2 for instance, and I set the name of this guy to be something else, let's say nose maybe, and let's take a look at what happens inside of our member variables. We make the assignment here, and notice I'm setting U2's name to nose now. Notice that U1's name changed as well, and U2's name changed, because both of these are pointing to the exact same piece of memory. Now when we go and destruct, where the bug shows up is our destructor up here says, okay, if this name exists, go and delete it. Well, let's put a breakpoint in here and run our code. We go into here, and as soon as we execute this line of code, what we're doing is we're actually deleting the memory that was associated with U1. You notice that the memory space 323C20 is the memory space that U1 is using for its name. It's going to go in here and delete that memory space and set it equal to null. Everything is fine the first time through, but then if I continue running, U2 has to delete its own memory. But notice U2 is pointing to that memory which we've already deleted from U1. And when we go into here, it thinks it's valid, but it no longer is, and we're going to try to delete the memory a second time. And that's whenever we get this breaking error here, because we are double deleting our memory. We don't want to do that. So to fix that, we need to create a copy constructor to allow us to copy the values from U1 into U2. And when we do the copying, we're going to allocate new memory into U2 so that we're not sharing the same stuff in U1 as we are in U2. Now, it's not a problem with the other member variable, age, because age is a member variable which is not a pointer. This is only a problem when you're using pointers, or in other words, dynamic memory. And I can demonstrate that. Let's say we go into here, and let's pull this out to be public so that I have access to it. And inside of here, we're going to change the age of U2. Let's make him 30. Now let's run our code and take a look. Let's take a look at U1 and U2. Notice that U1 is age 20, but U2 is age 30. So we don't have this problem with the addresses pointing to the same spot. We only have the, sorry, let me rephrase that. After we do the copying, C++ will automatically copy the age from 20 over top of 30. So our age now is copied over, but we don't have to worry about there being a bug with memory allocation because this U2 values for the age is not using a pointer. And to demonstrate that, I guess a better way to do it would be to do the following. Instead of setting a name here, and we can delete this guy here. If I run this program like so, there will be no bug. At least we won't see a crash. See, both of them are no name, and it exits completely perfectly. There is no crashing. It's not crashing because we didn't allocate memory from one class to another, and we're not copying the same memory space. These variables here are independent of one another. I can go in here and, for instance, that was a bad example. Let me put it under here. U1 is going to be age 20. U1 is going to copy over to U2, so his age will be 20, but then I'm going to override it with 30. And if I run this program, and then we take a look at the age values, we'll see that these two ages are going to be different. Notice U1 stays at 20 and U2 becomes 30. So both of these are independent. They have their own memory space. However, the names, because they're dynamic and they're pointers, they're going to be the exact same memory space if we use the standard equal sign the way it is, with no copy constructor implemented. So that's why we need to create a copy constructor. So to create a copy constructor, this is what you do. We're going to begin by overriding the equal operator. So we can do this by typing in const, and then we're going to be returning a user address. We're overriding the equal operator, and this guy is going to be accepting a constant user address on the right-hand side of the equal sign. First thing we do is we check to see if this, which is us, is not equal to this parameter here. Now, what this means is, for instance, if the user, for whatever reason, tries to do something like this, U1 is equal to U1, we don't want to be able to do this because in our code it would break some of our functionality. So to prevent that from happening, we check to see if ourselves is equal to the value that gets passed in here. If it is, we're just going to skip over everything and just return this, which is ourselves, therefore allowing us to be equal to ourselves and nothing has really changed. However, if these two are not equal, then what we need to do is we need to copy over all the values from user into ourselves. So all the variables here that we see m_i age, this belongs to us. And another way to do this would be to use this and then explicitly say use the age parameter. But you don't need to do that if you're inside of your own function. Alright, so we take the age and we equate it to the user's age. The next thing we do is we take our own member variable that will contain our name. We check to see if something is assigned to it. If it is, we'll first clean it up, set it equal to null, and then we check to see if this user has a name. If he does have a name, then we're going to allocate some memory for ourselves. This belongs to us. And then we're going to copy over into our own space whatever the user's name is. And after that, we return ourselves as an address. So that's what you see here. Now, when we go and run our program, you'll notice a big change. Oh, I meant to run it in debug mode. Okay, so here we go. We have SZ name is set up to be null, and here it's null as well. Oh, that's not quite right. I commented out the code here for our name. So let's just exit out of this and go back into our code, remove this, and remove this. Okay, now when we run our code, let's see what happens. U1 has the name Matic associated with it because that's what we have assigned it here. And U2 currently doesn't have a name because by default we just leave it blank. Now when we equate these two, look what happens. U2 gets some memory address allocated to it, but notice that the memory address space is different than the address space that U1 is using. The value is the same. It still says Matic, but now it's actually the different memory space. So these are no longer sharing the same memory space. And when I go and set the name for U2, notice that only U2's memory space changes. U1 stays the same. So we fixed the problem that we had earlier. And as a matter of fact, if we just continue running now and remove these breakpoints, you notice that there is no more crashing. So that's how we can get around the problem of assigning values from one class into values of another class. Now, there is one other thing you always need to do when creating copy constructors, and that is overriding the constructor. Now, the reason why you need to do this is because the user may do something like this. You would think that this would behave in exactly the same way that the previous code would. All I'm doing is I'm defining U2 and I'm assigning U1's values into U2. However, notice that when I run this code, it crashes. And this crashes for the exact same reason we were getting the crash earlier. If we go into our code and I place a breakpoint right here and I run it, notice the memory address spaces here for the name. After the assignment is made, both U1 and U2 are now sharing the exact same memory space. So even though there's an equal sign here, we never actually called the equal operator. C++ handles this kind of assignment a different way. It actually goes and tries to call this guy's constructor by passing in this type of class into it. But because there is no constructor that accepts a user type, what it does is it defaults to the default behavior, which is basically copying value by value whatever is inside the one class into the other one. And that's not what we want because we're using a dynamic value here, which will mean that we're going to copy over a pointer and then we're going to share that pointer among two classes. So to fix this problem, what we need to do is create our own constructor that accepts a user type. And here's the code that does that. We're going to create another constructor which takes a constant user address, and once we're inside here, we don't need to check for this because we know that as soon as we're constructing something, we're always constructing something uniquely. We don't actually exist yet, so there is no this that we need to compare with. We're going to take the user's age and save it into our own age, and then we're going to assign the name parameter for ourselves equal to null. If the user has a name, then we're going to allocate some memory for ourselves, and then we're going to copy the user's name into our own memory space. So now when we run this program, and we still have the breakpoint here, you'll notice that when we look over here, we now have Matic copied over, but it's a different memory address. So both of U1 and U2 no longer share the same memory space. And we can continue running the program, and it exits completely without crashing. So that's what copy constructors are all about. If you have dynamic memory, such as pointers, you have to be very careful when using classes. And especially when you're trying to assign one variable of a class to another variable of another class. If you're having dynamic memory allocation, you could end up crashing your program whenever you're exiting because you're cleaning up something twice, and the compiler doesn't like that. So I hope this video was helpful, and if you have any recommendations on things you'd like to see in the C++ series, just send me an email and I'll make you a video.